Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost log.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control.
Yo guys, I'm back.
To the landing target.
Guys, listen. Now the epic moment is about to happen. I'm just right on time here to see, hopefully to see how
going about 1 kilometers per second
will this new rover manage to land on Mars. I have several questions about this
which means
that I'll try to answer.
No longer trying to control the distance to Mars, to the target of Mars, but instead is flying straight to the target.
As of now, we'll just watch this live stream. It's directly from NASA Twitch channel, so I'm just like rebroadcasting this just in case there is somebody who is not there live watching. Also, you cannot see the chat there because it's just an emote spam. You see, there's just nothing there to see. NASA just limited that. So it's better this way.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
15 kilometers from the surface. Alright.
MRO is reporting good telemetry log.
Guys, what I don't understand here is how they're live streaming this.
Coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
I mean,
the navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Okay, we have the parachute. That's good. That's good. But I don't know how they can stream this in real time. Like, that's just impossible.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Okay then.
Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Okay, but why are they lagging?
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have timing of the landing engines.
I don't know about this.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the Divert Maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Okay. Soon to be a touchdown.
We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
What?
As expected. As expected.
Sky crane maneuver has started, about 20 meters off the surface.
Oh, it landed.
We're getting signals from MRO.
UHF is good. Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
I have several questions.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it. We're
Touchdown
there.
confirmed. We're going to wait for the images.
We wanna wait
This
for
is
the
so
images
exciting.
now,
The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
Great.
So much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
I'm really curious about one thing.
Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
All right. Captions.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
What? It's black and white? It's black and white image?
I have the target point on the map when you are ready. We are ready, OL3. Go for it. Flight, I'll be moving in, showing you the safe zone that we've landed in.
The team has just put the first image from Perseverance on the surface of Mars.
This is
Now,
just
it
bizarre.
comes from the engineering cameras known
We gotta
as
celebrate
the hazard
this.
camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
But why is this black and white, dude? Come on. It's 2021.
This is amazing.
Steve?
If only I could ask them a couple of questions. Like, how is it possible to live stream directly from Mars to Earth? Live. Like, no delay. I thought that was not possible.
You did.
I mean, it's literally 8 months away. How? Is there a new technology or something? Like, this all looks staged to me. Even this applause is kind of cringe.
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there.
Imagine
they're a little dirty because
the third picture, and there is aliens there.
But we took these
posing.
seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing.
No
And,
way,
we
dude.
even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country. On all of the problems we have, we need to work together to do these kinds of things and make success happen.
Yo, guys. I don't know.
Joining us now is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you.
Hey,
what
Steve.
an amazing day.
And how does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions, and then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment.
Bring
in
back
our
the new
laboratories here on
viruses
Earth.
from Mars on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Okay, I have several questions.
Hi, my name is Landon Applegate. I'm in 6th grade and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith, and then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
Okay, Steve,
And
but how is it
now
possible
that Perseverance has
to live
safely
stream
touched
directly
down
from
on
Mars without delay?
Let's learn
How
more
is
about
that
what's in
possible?
store for the rover. Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes, hi Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the commanding team will be working overnight while the rover is asleep so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks. So it'll be exciting and some late nights, but we're also excited and we can't wait.
I don't know, this is not that exciting to me, guys.
We also have a student question for you. This is Sophia's video.
Hi, my name is Sofia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
Wow.
Well, Sophia, Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well, thanks for your time, Jessica, and good luck living on Mars time.
Thank you. Should be fun.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to be here. You can see all my mask markings on.
Well, you were just celebrating, and rightly so. Now, you've been around for a number of Mars landings. What makes this one special?
Well, you know, two things. I mean, it's the biggest and best rover we've ever sent to Mars, and it can really, you know, do amazing things in terms of, you know, its own scientific exploration of this habitable environment, you know, at Jezero. But, you know, it's also, as you've heard today, you know, it's the first step in Mars sample return. So really, you know, it's not only doing its own mission, it's setting us up for a series of missions and to bring those samples back. And, you know, a lot of the effort to develop the rover was specifically designed, you know, for that sampling and caching system. It's one of the most complex robotic systems ever made. And, you know, having it down safely means Mars sample return continues right on course, and we are moving forward.
Wonderful. Now, JPL has a long history with robotic space exploration. Why do you think it's so important to continue to push those boundaries?
You know, there's a lot of reasons. I mean, obviously, you know, for places that are far away, like Mars, and even farther away, you know, like Europa, right now, robotic exploration is the only way we can make these scientific discoveries and really understand these early habitable environments. In the case of Europa, maybe it's even still habitable. And, you know, we're not ready to go there with astronauts yet, but the robots are ready.
We will never be.
And so we always, you know, are forerunners and
it's always going to be a robotic
of human exploration. And we start by sending, you know, our eyes and
there's just no
arms
need
there
for humans to go there.
And it is just
when
fantastic
robots
to be able to
can
do
do
that
all the work.
and to learn from each rover, learn from the science and the engineering, and make the next one better and make more and more discoveries. And every time we do one of these missions, we make fabulous discoveries, and you know, each one is more exciting than the last.
The future does look exciting. Now, as director of JPL, what would you like to say to those teams right now celebrating?
Oh, you know, obviously they have earned it. Let me tell you. I mean, they have worked, you know, for years and years on this mission, and then in the past year, of course, we had the COVID experience, and you know, I want to thank not only the team but also, you know, all of JPL. You know, a lot of folks had to pitch in here, you know, in terms of making sure our remote telework, you know, our IT systems were good enough to support folks working from home. You know, all of the folks looking at PPE
guys,
and our safe distancing.
How is it possible to live stream directly from Mars to Earth in real time? How is that possible?
Amount of work by the entire lab, and of
It's
course,
not
especially
possible.
by this team. And you know, and in one sense, you know, the
Live
7 minutes
demo.
of terror are very exciting. But on the other hand, you know, the mission's just started, right? We built the mission, you know, not to land, but actually to drive and get the samples and do other technology, you know, demonstrations. And so, you know, for much of the team, you know, this part of the mission's over. But for most of the team, the mission's really just starting. And so, you know, I think they're very excited. But you know, everybody, I think, can take a deep breath and a sigh of relief now that we are safely down on the surface.
Yes, that collective sigh of relief, and I hear a lot of excitement and celebration behind me as well. So thanks so much for joining me, Mike.
It's my pleasure, and thanks to everyone for joining us too.
Congrats again to the Mars
Thank you,
2020 Perseverance
gentlemen.
team for a successful landing. Back to you, Raquel.
Now, there will be a flight test coming up for the Ingenuity Mars helicopter, and if this technology experiment is successful, it would mark the first time we have taken a power-controlled flight on another planet.
Oh my god.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first
Hopefully
time,
this goes well.
experimental aircraft. And in the same way, the Mars
Čemu je
is
reč?
designed to show that we can
Gle.
fly power helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do the very first rotorcraft flight test in the actual environment of Mars.
Fora je,
It's extremely difficult to fly at
fora je da
Mars
su
because the
upravo,
atmosphere is so thin.
upravo
At
su
Mars it's less than 1%. So the first and foremost
sleteli ili je sleteo najveći ikada napravljen
the second is to
rover
generate lift. The rotor system has just been very fast.
u ljudskoj istoriji, upravo je sleteo na Mars.
We're spinning between
I ovo je bio live
2000
stream
and 3000
koji pratim,
revolutions
međutim
per
to nije
minute,
sve.
and it takes a lot of energy. So it's that balance
To
of
nije
a
sve,
very light
na
system
tom roveru postoji i
having enough
mini
energy
kopter, koliko
that's needed
vidimo
to,
sad.
you know, spin the rotor so fast to lift, and on top of it, having to design in the autonomy
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here.
I to nije sve, ta misija treba da sad prikupi, šta oni planiraju da urade sad? Da skupe uzorke i da te uzorke pošalju nazad na zemlju, po prvi put u istoriji.
Very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second.
Nego ono što meni nije jasno je to kako je moguće da live streamuju direktno što se dešava na Marsu u realnom vremenu. To mi nije jasno meni. Ali nisam od početka pratio, tako da možda ima disclaimer negde kako je to moguće, ali ja ne znam trenutno. Ja koliko znam nisu mogli da održe live komunikaciju ni sa posudom koja je išla mesec, brate, koji je mnogo bliže nego Mars, a ovo sad ispada da direktno tamo znaju što se dešava. Što je veliki napredak u tehnologiji, ako je to stvarno. Ali pre bi rekao da je se ovaj event desio već i da su na osnovu njega napravili telemetriju i da onda kao fake streamuju. Kao live stream trenutno, a ono što prikazuju se u stvari desilo možda pre par dana. Mislim da je to.
What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Mimi Ong is the project manager for Ingenuity. She joins us now as they await a chance to check out their helicopter in the coming days. Welcome, Mimi.
Thank you, Marina.
Oh my goodness, we've been talking about this for months, Mimi. Did you ever think you'd be here at this point? I mean, what's going on in your head right now?
Da li da čekamo uopšte da vidimo taj helikopter kako će leti na Mars ili da ga zajebimo odmah sad?
Testing and carefully designing it for operation at Mars. So what's going through my mind? Ingenuity Mars helicopter is finally at the destination that it is designed for.
Now that Ingenuity is on Mars, what is the timeline you hope to accomplish as you move forward?
We have a series of major milestones between now and Ingenuity's first flight. So tomorrow we'll turn on the helicopter and its base station to confirm health after experiencing the dynamics through the EDL just now. And the next major milestone will be when the rover deploys the helicopter to the surface.
What the fuck? There is a space station around Mars already?
Ingenuity operates on its own in a standalone manner. And surviving that first cold, frigid night of Mars will be a major milestone.
Even if there is, it's just a primitive space station, that's for sure.
And then we will perform that very important first flight. And if the first flight is successful, we have up to 4 more flights in the 30 Martian days that we have set aside for our flight experiments.
And that's when you finally can breathe, right, Mimi? Now, why is it so important to have that aerial dimension to space exploration?
A helicopter flying far ahead of rovers and astronauts in the future can provide high-definition reconnaissance information for the rovers and the astronauts before they take the long journeys. And as importantly, being able to fly will enable us to get to places that we cannot get to with rovers and astronauts, like sites of steep cliffs, deep inside crevices, areas of high scientific interest. It will be game-changing.
Game-changing is right, and we've talked about this a lot. You've mentioned the risk is huge, Mimi, but the reward is high. What will be your greatest reward?
You know, our team started with the question of whether a helicopter can fly at Mars, given the extremely thin environment. And we systematically demonstrated a series of technical steps. We demonstrated lift first, and then we demonstrated lift and the first ever powered control rotorcraft flight in simulated Mars atmospheric density. And then we went on to build the full-up helicopter that can not only fly, but operate and survive autonomously at Mars, all under 1.8 kilograms, about 4 pounds. And each of these major milestones have been a first. And the success at each of these
all
has
worked
been
out
so
of the
rewarding.
first get-go.
And along the way, the
That's
rewards
impressive.
just kept coming, and I have to tell you, at this moment, it's going up exponentially. So after all these tests, analysis, simulations, and more tests on Earth, our team now gets a chance to test, prove, and learn how it works in the actual environment of Mars. Our team can't ask for a bigger reward than that.
Oh, Mimi, I'm so happy for you and your team. And now we're going to take a question from social media on Instagram for you.
Oh.
At Not Vibhuti asks, is the helicopter going to be doing science?
Well, the helicopter Ingenuity is a technology demonstration. And we are demonstrating the ability to fly and learning how to fly for the very, very first time. And so this is a technology demonstration and a pathfinder for future larger rotorcraft, future missions that will carry much larger instruments. So on this mission, we're not doing any science. We're concentrating on engineering,
He'll just fly.
data, how did the vehicle perform? And as you saw Bob Belram in the video before, we will be taking a few first ever color pictures from the flying aerial vantage point, but they'll be icing on the cake. For this one, this is all about engineering data and how do we fly compared to all our tests we have done on Earth.
Mimi, so much for your team and the future generations of scientists and engineers to look forward to.
Looks so good, actually.
Thank you so much for joining us, Mimi, and good luck to your team.
I mean,
with
if this
that
is all
first
true,
test flight.
this is just amazing.
Thank you so much.
Now we look forward to the Perseverance rover and Ingenuity helicopter beginning their journeys on Mars as their adventures are just about to start. Go Perseverance and go Ingenuity. Back to you, Raquel.
Thanks, Marina. Landing on Mars is never easy, but this team has persevered, and NASA's 5th rover is on the red planet. You can still hear them buzzing in the back
Fifth
right
rover,
now.
it's 5th.
And to get the latest updates on
fucking Mars is full
Perseverance
with
as it explores
machines
Mars,
now.
follow at NASA Persevere on Facebook and Twitter. I'd like to thank everyone watching for joining us today. And to the students and teachers tuning in, we hope you learned a lot from today's landing. And thank you for all your questions. We have a news briefing coming up at 2:30 p.m. Pacific time. That briefing will wrap up the day and include reactions from Perseverance team members. We'll leave you now with some of the landing celebration photos you've shared with us, set to Youngblood's cover of David Bowie's Life on Mars. I'm Raquel Villanueva. Thanks for watching.
Thanks for watching, everybody. Yep. That's about it. Until the next time we land on Mars.